If you're having a hard time modeling conditional logic in Simulink, then you've come to the right place. Else, I hope you stick around and learn something new. Hi, my name is Eric, and today we will be talking about conditional logic in Simulink, where you can modify output signals based on inputs. Conditional logic is especially useful in modeling nonlinearities of systems, but it can vary in complexity, from a simple switch block on one end of the spectrum to complex logic in a stateflow chart on the other. To help us understand different scenarios across this spectrum, we will consider a smart lighting system. We will employ a conditionally executed subsystem to model the light bulb. These subsystems execute based on conditional logic. In our case, a signal will control whether the light bulb is turned on or off. Let's start with the most basic form of conditional logic, the switch block. This block works by taking in a control input to toggle between two possible output signals that are provided as inputs. Consider a light switch. The control input is the on-off toggle. When it is flipped to on, the light bulb goes on, and when it is flipped to off, it turns off. Let's take a look at what this would look like in Simulink. This block has three inputs. The first and third are possible outputs, and the second is the control input. So, when we toggle the control input, the light turns on and off. The next step up in modeling more complex logic is the If-Else block. You have a high degree of freedom with this block, with the ability to model multiple inputs and actions. Consider a more sophisticated lighting system. Depending on the time of day, you may want different lighting configurations, such as the overhead lights to turn off when the sun goes down, leaving on just the lamps. This kind of logic can be defined with an if-else block, where the inputs contain multiple control signals that affect the output signals. For more complex conditional logic, where different modes of operation or states need to be used, Stateflow provides a simple solution. With Stateflow, you can describe the interconnected logic that determines different operating states of the system. Your states can become complex and nested, flexing the full logical capabilities of Stateflow. Consider a more complex smart lighting system, where you can control the color, brightness, and even different lighting fixtures with different modes. Instead of implementing conditional logic for the different subsystems individually, you can define a single stateflow chart with different modes or states of operation where it is easy to visualize, test, debug, and generate code. If it is nighttime, you may want your default to be that the overhead lights will turn off in preparation for sleep. However, if you change the mode to party, the overhead lights can turn back on and begin to change colors. The entire system can also be turned off with the control input. With Simulink and Stateflow, you can implement conditional logic as simple as a switch and as complex as state charts with nested logic and parallel states. The approach you should take depends on the complexity of the application and the level of fidelity you choose to model. If you're interested in learning more, check out the Getting Started with Stateflow video, read one of our embedded software user stories, or explore the documentation examples, all of which are linked below. Thanks for watching.